Today, we're going to be talking about something that's pretty hot right now. We're going to be diving into the world of MLOps.
Oh, yeah.
And
It's
specifically,
a good one.
we're going to be looking at professional certifications
Yeah.
in this field.
Nice.
Yeah.
MLOps is,
If you're out there and you're thinking about maybe getting a certification in this space,
yeah.
this is the episode for you because we're going to be talking all about what it could mean for your career.
So today we'll have a discussion about the Knative, and also we'll have a demo as well. So today I'll give you some sort of demo as well, how to use Knative, and accordingly we'll go ahead. So what is Knative? So you might have heard about the function function based architecture. That means function as a service or something like that, which we had Lambda in AWS and Azure functions.
Yeah,
Of yeah. So Knative is not a function. Uh, it's not Lambda. It's not a function as a service. But Knative is basically a kind of platform where you can run a program without worrying about the the infrastructure, without worrying about the servers. Okay, so there is a two concept: serverless and function as a service. So these are the two different concepts. So here when we talk about the serverless, it's not like a less servers you have it and so on. So here we are discussing more the dynamic infrastructure, where there is one infrastructure which has been created by your IT team, and anyone can use that infrastructure and uh, and run their application for the production. Okay, make it available for the high end, and let's say if there is no traffic for that applications, in that case also you are not paying for it. So in a normal scenario, what happens, like you want to run some certain application in the production, so you typically run EKS cluster, Kubernetes clusters and all, and then no matter whether the traffic is there or not, you will keep paying for that infrastructure. In this case, uh, when we are going for the Knative, you can run the infrastructure only. You can run the application only when there is a traffic. If there is no traffic, so the application will not run, and then application will not run, so ultimately it will not consume the infrastructure. So that way, again, the same clusters, it can be shared to host the multiple applications from the different departments and so on. So this can be, it can help you to reduce the cost a lot. So here, yeah, dynamic infrastructure is an IT concept whereby underlying hardware and software can respond dynamically and more efficiently to changing level of demand. So now this is the modern cloud infrastructures. We all are running everything in the containers and with the Kubernetes, so that we are aware of it. So what we do in order to set up all these things, so we do provisioning, orchestrating, scheduling, certain network automation we have. In order to run in application network segmentation, we have traffic shaping. Then we set up observability, service registry, discovery, and service configuration. So these are the component you required to make it to use it to make the production ready infrastructure for your applications. But here, when we go for the serverless architecture, serverless platform, whereas provisioning, servers configurations, orchestration, and service discovery and other stuff can be a part of serverless architecture, platform itself. You don't have to do separately. That means everything will be taken care by this platform, serverless platform. Okay, so as I was talking about the function as a service, so serverless platform which is taking care of all this stuff. In You don't have to worry about any of this stuff which I showed you. Function as a service, which Lambda and all, where cloud provide certain place where you can run certain small code, which is like your function, and you get the response code. So function as a service in which the code is like a shortly lived, probably for few seconds and minute, and it's a single threaded. So that's a functionless. So serverless versus function as a service, both are different concept. So here serverless is not a fast. So don't get confused here. Serverless is a fast. Function as a service is a not a serverless. So some of the things which is common, some of the things are different here. So when you look at the serverless, it's a multi-threaded server, runs on the multi-threaded server, and serverless is a cloud provider agnostic. That means your platform can run on AWS, Azure, Google Cloud, or many other platform, private and public. For the end user perspective, you have no realizations of it. Whereas function as a server is a cloud specific. That means Lambda is only for AWS. Function, Azure function is only for Azure, like that. Serverless function, you can run the long-lived jobs, which is required days to run. And whereas a function as a service is just a few seconds or minute, right? So these are some of the key differences between the serverless and functionless. So now the question is where the Knative is coming into the picture. So with a little bit of introduction of serverless and function as a service, what is a Knative then? So basically Knative again is a kind of platform which runs on the Kubernetes again. So Knative is a Kubernetes based platform to deploy and manage modern serverless workload. But remember, it's not a function as a service. It's a serverless workload. That means if you want to set up the infrastructure where uh, let's say you scenario number one, if you want to deploy your applications to the production, step number one, you have to set up a servers. Step number two, you have to install the platform. Step number three, you have to deploy your application and make it live. Correct? No? These are the things. But here in a serverless, you don't have to set up a server. It's already there. You don't have to set up a platform. It's already there. Just you come up with the application and deploy it. Don't worry about any of the backend behind the scene. Okay, so that's a concept. So how can we create this serverless architecture? So Knative is one of the applications which is helping us to deploy the serverless architecture. So we deploy in the Kubernetes itself. So Knative have a multiple hierarchy. So here Knative runs on the Kubernetes only, which you know that very well. For the networking, they have a multiple plugins. So Contour, Istio, Glue, Kong, Courier, Ambassador. So many networking layers it can be used. One of which you cannot use everything. One of which, let's say you can go for Contour or Istio for the demo or something like that. Ambassador is a paid one. And then on top of that, you install the Knative. Make sense? So if you want to set up a Knative, first you set up a Kubernetes. Now Kubernetes you can set up on AKS, GK, and whatever, bare metal as well, and then top of networking, and then top of Knative. And then Knative will become a platform to manage all the serverless application which you want to host it. Okay, are you understanding?
Yes.
Okay, so I'll give you one simple use cases to visualize this, the advantage of Knative. Let's say my application which is offering my companies which is offering the trial account for the services. So for that what we do, uh, trial account, the moment any user is registering for the trial account, we'll have to create certain infrastructure, certain storage. So we have to run one piece of software for that user for 30 days. Correct? So now whether the user is using that trial account or not, we still run that infrastructure, still run that storage, we still run applications, still it is consuming CPU, RAM, and stuff like that. So that is the cost for the cloud, right? Because ultimately you are running, assuming that you may get this user converted into potential customer or something like that. But in this case, let's say if you run this application on Knative, if the user is not active and user is not using that infrastructure, it will not run and it will be 0. So that means your cost for running your application on Knative is 0 virtually. Are you understanding? So the moment he will log in and try to access the application, immediately the whole infrastructure or applications, whole not infrastructure, applications will be created on the fly based on the request. Okay, so that is called serving. Serving means the moment you ask for it, application will be deployed. If you are not asking for it, automatically it will destroy. You're getting my points?
Yes.
Yeah, so that is something. So earlier, Knative, we had a three software we had it. Okay, so earlier we had a Knative Serving, and then we had a Knative Eventing, and then we had a Knative Pipeline. Three components we had it earlier. So what we did, uh, we keep I mean, the Knative is having the right now the serving and eventing in currently, and the pipeline component they separate it out and made it a new product that's called Tecton. Okay, Tecton pipeline, you might have heard about it. So that is a pipeline. So we will learn only the serving and eventing in this case. So for the networking, you can use Istio and Kubernetes. So these are the things. Okay, so now where can you run Knative? So basically you can run anywhere, wherever you can run Kubernetes. And you know that Kubernetes you can run anywhere. So Knative as a service, let's say uh, let's say you don't want to run your own Knative. Okay, you don't want to run your own Knative. So in that case, do we have any SS services which you can use as a service also? So Gardener is a one, Google Cloud Run is a one, IBM Cloud Code Engine, Pivotal, Red Hat, and Trigger Mesh. Some of these options where you have a Knative as a service you can run. Let's say if you like to explore the alternatives for Knative to set up a serverless architecture for your application. In that case, the leading products are like Apache OpenWhisk, OpenFast, Fission, and Kubeless. So these are the alternative for the Knative. Okay, so this is something which we have. Any questions so far? Okay, so now before setting up the Knative uh, setup, let's understand that I just said there are two part of it. One is eventing for the Knative, and one is serving and eventing. Okay, so primarily it's a serving we are discussing. So I just said, just to recap, if you want to host your applications for the production, you are needed all these components, different types of software, whereas you can minimize this by the Knative. Okay, so how it works? So look at this. This is the architecture, how it works. So first, user. Let me explain it to you in a simple way. Okay, so what happens? First thing, these applications. Okay, which is not when this application is, this is nothing but the pod. Okay, so pod has a certain service. Okay, and service, you know that service is not consuming any CPU and RAM. So this is the pod application, and you create a service, and these services have a configuration, that version 1, version 2, version 3. So this we deploy that applications in a Knative. How to deploy? I'll teach you. Okay, now what happens whenever we user make a request through the route, this route is from it can from your networking component like EHT or something, or ambassador or something like that, or anything load balancer or something, Istio gateway also. So one you make a request to that URL, and then this route to this particular service. The moment this service get a traffic, this pod get created. Okay, simple. So till now the pod was not created, but the moment it got traffic, the pod got created. Now you get a more traffic to this route, more pod will be created. Okay, you get a less traffic, this pod automatically will get destroyed. Okay, so this way you can don't have to worry about the infrastructure, and you keep deploying the applications like this. Did you understand this?
Yeah.
Okay, so here how it works. So in Knative we have there is one controller which basically manage the service and configuration and revision to the number of deployment. Deployment is like number of pods what you have in the Kubernetes. Okay, now I just said controller is linked with Autoscaler. So the moment you have more traffic, the pods, number of pods will be auto scaled, right? Or down, it can reduce or it can upscale or downscale. So that is done by Autoscaler. Autoscaler is an inbuilt component in Knative. There is one external Autoscaler. You can also use it for this matter. Okay. So overall, these are the components which we have: controller, activator, Autoscaler, some certificate if you need it for networking issue, and some webhook for eventing. Okay, so this is something which we have. Now, as I said, like we have a two kind of Autoscaler. The built-in is a KPA, which is a Knative pod Autoscaler. The moment you deploy the Knative, you will get the KPA. Now let's say if you want HPA, HPA is based on the Kubernetes. So if you want the Kubernetes HPA, you have to configure accordingly. So again, if you see some of the characteristics, if you use a KPA, which is installed by default, you can scale to the 0, and it can increase the number of pods based on the request. Whereas here in HPA, it's a Kubernetes offered as an extension in Knative. No scale to 0. That means minimum one has to have it in HPA, and so CPU based auto scaling happens. You know that HPA is a Kubernetes component. Okay, now let's say if you want to deploy the code and you have to deploy the service in Knative. So how do you do that? So this is the YAML code for deploying one service. In this case, what you are doing, service serving API version you are calling up. That's operator which you have to install it. Kind is equal to service. This service is your Knative service, mind it, the name and namespace, and here you are deploying the one image, which can be anything here. Simple code, and then you deploy this code one KSBC, that means Knative service will deploy. Okay, there's some more specifications for this here. Here you are saying, hey, don't use the default uh, Knative autoscalers, use the HPA autoscaler. So here you are annotation, passing the annotation in metadata, and then accordingly. Okay, so some of the metrics and target based on that you can auto scale, which is like a concurrency, RPS, and CPU. So these are the three parameters. Based on that, you can do that. Concurrency means 100 in flight request. Example, let's say if you have a total 100 request, you can increase the number of ports, or maybe your response rate is 200 requests per second. The request rate is 200 requests per second. So you can increase the number of parts or HPA based on the CPU. See here, this is the how you define the concurrency, which HPA method you want. So that auto scaling Knative dev metric concurrency and 20 or whatever it is. Okay, here RPS and here is CPU. Okay, so this is something which we do that. There's some soft limit, hard limit also. It's not important for time being, and so on. Okay, so any questions so far?
No.
Okay, so this is something which we discuss. The user will make a request to the route path. Path will redirect to the service, and service based on that your application will run. Now what happens? So service again check the multiple configurations. Configuration, you can have a revision 1, revision 2, revision 3, and based on the revision you can run that application. The beauty of Knative is you can run separate revision also. For example, let's say you want to have this service, one service to load a new revision and one service to load a new old revision. Both is possible, so that way you can run the old version of software also and you can run the new version of software as well. Okay, so see here, here as part of this image you are saying, hey, my the user redirect to the latest version of revision of my service. But you can configure something like total traffic 10% goes to the new revision and 90% of the traffic go to the old revision, which is revision 2. So those are the things also can be possible. Here again scenarios, revision 1 50%, revision 2 50%, and revision 3 for the testing purpose. So that also can be done. Okay, so now let me show you the demo for it. So what I'm going to do, I am going to set up a Kubernetes clusters for that. So let me set up a EKS. So first thing is I'm going to use this one report, this report to create a EKS cluster. So let me clone this one. Okay, so now I am going to so here some of the files I probably have to check that. So let me open up this file. These are the Terraform codes. Okay, so I'm just checking which particular region I want to deploy. So I'll go for Asia Pacific South one, that means Mumbai region. Okay, so variable, this is the one, and so these are the providers will be downloaded: AWS, random, TLS, Cloud Init, and output, and this is the main code. So new VPCs will be created, and NAT gateway and NAT single NAT gateway. This might take a little longer time, so I will make it false, false. I'll just leave it. We'll try later. It will cost us, and cluster name, and this is the node group. So max size I'm making it 2, and here this is the T3 small. So basically I want little larger, so T3 large. Okay, so this is something which I wanted for one max size 1. So two machines will be created overall. Now this will be the OIDC authentication. So good to go. Now what I will do, I'll configure AWS. So configure AWS is not installed. So let me install the AWS in this machine. AWS CLI Windows. Okay. So and I think it should be there. I'm not sure why it's not detecting. Okay, maybe it's new laptop, right? Yeah. So no worry. Let me install the AWS CLI. Yes. Done. Okay, so now I have to reopen this one. So let me go and okay, AWS. Now it's coming. Okay, so now I'm going to configure AWS. It's a one-time activity. So ID, let me get it. So so access keys are here. So I don't have any access keys. So let me generate one and enter, and secret key, enter. Okay, and region we decided we'll go for AP South one, right? And none. Done. So AWS S3LS, I'm just checking it's working or not. So yeah, it is working. So now it is done, and now I'm going to run this apply. So I think more or less I did this. I'm just checking the code. Okay, so now I'm going to run this command. Terraform init, spelling mistake. Done. Okay, so now I'm going to apply for it. Apply, enter. So this will create a whole new EKS clusters for our use. Okay, so 67 resources to be created. Say yes. Okay, so now it will take a couple of minutes to get it created. So now we will get all this thing done. After that, we have to configure our kubectl. So let me check my kubectl is there in this laptop or not. So I'm checking this one. I'm opening up a new console. kubectl, and I think it's there. Wonderful. So we can just need to configure it after the once the Kubernetes EKS cluster is created. So here you have all the steps to do that. So here you can get it. It will take, I think, 2 minutes more. be done now, by now in few seconds, I guess. It's taking a little time. Just let me check manually. So go for EKS. Let me check what is the status of it. Yeah, it has been created and is creating. So yeah, it's taking a couple of minutes more. We'll have to wait for it. So let me pause the recording.
This conference will now be recorded.
Okay.
Okay, so whole clusters with NAT gateway, VPCs, and everything got created. Overall 67 resources, and this is my clustered endpoints. This is the cluster name, this is the security group ID and region. Now I need to set up a kubectl configuration, so let me do that. So for that, uh, though you can see the all the configuration items anyways you have on the here, but I'm going to need this command to run it. Now this command will automatically configure your kubectl for connecting this. So AWS EKS here update kube config, and from this cluster, so the AWS configurations already is there, so it will fetch everything and set up my yeah, in this file it is set up. So kubectl is configurations is done. Now let me validate if my configuration is okay or not. So cluster info, it's all Kubernetes commands and done. So now you see that here everything is good, and I just want to check the nodes as well. So two nodes I have added, two nodes group, and should be done. Yeah, so both the nodes are ready, and so each of this node has 8 GB RAM and two CPU, so that should be okay. So far what we did, we set up a VPCs, we set up a Kubernetes clusters. Any questions so far?
No.
Okay.
Yeah, I understood.
Okay, now what we will do, we'll deploy the Kubernetes, I mean Knative software, Knative platform. So how do you do that? So just go to the
So you
latest
will
doc.
be deploying this Knative software on the two pods, right? Two
No,
nodes. I mean,
no. Knative
mm,
is a platform. So on
okay.
Kubernetes, it will run Knative. Okay. So Knative is this application again. Yeah, it's a pod only, but it's a you in a word in a visualization way. You have to think about it. You are going to run your application using Knative. Knative is running on Kubernetes like that.
So this Knative will, in after running our application on Knative, it will be getting connected to that nodes, right?
No. Knative is just applications for the Kubernetes. It's an operator. It's an operator.
That I understood, Raj. I'm asking you. It's an operator, right, which will be running on Kubernetes,
Kuber.
right?
Yes, yes.
Yeah. So how will it interact with nodes then? Indirectly, the process will be the same.
Uh,
So it's
uh,
like a hyperware, right? Like just cloud down hyperware like that. It's just a platform which has in down Kubernetes running. That is what you're saying.
no. I'm saying here
Hmm.
Knative is a application which runs on
Hmm.
Kubernetes. So that means there is no connection. You should not say how it is connecting to node because anything, anything which is you are running on the Kubernetes runs in a pod and pod runs in the worker node. Correct now? So that way I'm talking about. It's an operator. So certain resources will be created in a master node, so which is EKS in this case, and certain resources will be created on the node side of it. Got it?
Okay, so you mean to say that this Knative will be running in each worker node. That is what you're saying.
Yes.
Application.
Yeah, it's application. So I'll show you that one. Yeah. So look at this here. Right now, these are the pods right now. Okay. Now these are the pod. See, get pods, all namespaces. So these are the pods we have right now. So these are the related to controller. These are the volumes. This is networking, DNS, and this is the AWS and stuff like that. So in EKS clusters, you won't see scheduler, controller, and this one API server. Okay, so these are the external resources. Now I'm going to deploy a Knative on top of Kubernetes. How do we do that? So here you have a Knative. As I said, Knative have two components: serving and eventing. So eventing is not that important. Serving demo I'm showing you. So serving, click on it.
You through this YAML, you will be writing script to connect to pod, that pod connecting to node, that node connecting to Kubernetes, that you'll be writing, Raj. Uh, for clarity, I'm
Mm,
asking. Or just for
Uh,
connecting to pod only you'll be writing.
Okay, I think I need to go a little bit basic again. So here, what I'm saying, understand this way. Uh, what I'm saying here is, uh, forget about Knative for a few seconds, okay? So let's say you have any software, okay? Any software, and which you want to deploy in the Kubernetes. And when you say Kubernetes, this is the master node, and this is the worker node. This you understand well, right?
Yes, yes,
Right.
yes.
Yeah. So what happens when you deploy this software in a form of YAML or Helm chart, whatever it is, and you deploy it to the master, and master will run the pod here, here, here. Correct now? Agree with me?
One second, can you come again with this point? You are
So
deploying
any
it?
software
Oh.
you deploy in
Hmm.
Kubernetes, it's in form
Hmm.
of YAML or Helm. You deploy it to API server in master,
Hmm.
and then they will
Yes.
create a pods here in worker node. Correct now?
Yes, 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 correct, correct, correct,
Yeah.
correct.
So now this software, you have this software now convert into, it's not a simple software. It is operators. Operators
Okay.
means CRD, custom resource definition. Okay. CRDs. That means kind is equal to pod. It's like one resources, right? So like now kind is equal to something else. We want it, which is not a part of the Kubernetes. So what is this? Operator, CRDs. Now this special software, when you deploy, certain resources has to be created here also, and then certain pods has to be created here also. Okay, so this software is your Knative. So Knative is a kind of application which is a CRD in a form of
Hmm.
operators, deploy on the
Hmm.
Kubernetes, create
Hmm.
some custom resources, and
Hmm.
certain resources they run to in order to run the Knative applications. Got it?
Oh, okay, okay. Got it. Oh, yeah.
Yeah. So now what I'm doing, I'm just deploying the Knative now, Knative Serving. Okay. So Knative Serving. So how do we deploy? So go for the installing documents, go for the latest one. And here I'm just checking. Here it is. Verifying the image. This is not required though. It's just to verify the image. And here install and Knative serving component. So that the first thing we will install the CRD. This is the operator. Look at this. Okay. So just simply copy and paste it. That's all. And deploy. It's the latest version 1.16. We are deploying it. Okay. Now remember that before deploying the Knative, I had these many resources, these many pods. Now your question is how many pods got created? Look at this.
Hmm.
So here I run this, and here did we get any pods?
No.
Why?
Hmm.
Because these are the CRDs. CRD means custom resources. So what we got it? So here we got it API resources. API resources. Let me show you. And go for the Knative. Do you see somewhere? Here, look at this. These are the resources. We got it. Let me, this one, let me do that grep Knative. Oh, grep command is wrong, I guess. So these are the CRDs, custom resources we deploy. Okay, see that, look at this. These are the extra things we got deploy. Earlier it was not there a part of Kubernetes, but now you got it. Understood? So this is a CRD. Now
Okay.
what we are doing, we are deploying the core component of serving. So this is the real software. Earlier I deployed the CRDs, now it's a real software. So copy and paste it. So these are the software you have. This is the real software core, serving core. Now if you look at this little carefully, cluster role got created, service account got created, and many other CRDs also got created. Few config maps got created. Now these are all the typical resources for the software. Now as you see the pods, deployment, services, all this thing got created. So this is the software. Now if you look at this, how many pods you got it? Look at this. See here. So these are the pods which is now you got it. Understood? And this is the which I was
Oh,
saying
okay.
activator. Remember the slides which I was showing you? Activator,
Oh.
autoscaler, controller, and webhook. So these are the four component of Kubernetes serving.
Raj, once
Knative.
again, what prior it wasn't getting reflected, now it's getting you what command what you did once again, please
I
repeat
did
that command.
install the core. No, this is software, real software.
Oh,
Okay. So
okay.
now I installed this one. So now serving got installed. Serving got installed and it's running also. There's no issues in this.
Okay.
Now when it's running, you have to install the networking layer. Now which networking layer? It's up to you. So you can go for Courier, which is easy to use it. You can go for Istio also, which is here, and you can go for Contour. So these are the three options we have. So let's go for Istio. So copy and paste. Done. Now I'm just checking istio got history command. I'm just checking both got installed or only one. So this is the istio component and this is the Knative integration. So this is the istio, okay, and this is the integration for Knative. That is done. Now this is two done. Now this is a controller for istio networking component. Done. Okay, so now these all done. Now you have to check that external IP address or CNAME by running this command. So ingress gateway, you have to get it the IP address. So ingress gateway, let me copy this in my notepad. So here, so this is the ingress gateway which we have. This is the one. Okay, DNS you can consider, and this is the cluster IP for ingress gateway. That means all the traffic which will come, it will come from the ingress gateway external IPs only. Okay, so you are done with it. Now after that, this command you can run and check that whether everything is configured or not. So for that, get pods Knative serving. So all the pods is running in the namespace which is a Knative serving, and I see the all the pods is running. That means there's no problem in this. So the deployment is successfully. Now DNS we don't need it. So when we don't need a DNS, that means no DNS. That means in order to check that, you have to use this way. I'll show you this one. This is the method to use this. Okay, so I'll show you this one. That's not a problem. Okay, so far so good. Any questions?
No, no, understood.
Okay, so now I'll keep this page open because I need to copy certain commands while testing it. Now I'll go and deploy one simple applications in this. So how do we do that? So here we check that application kubectl get KSVC. Remember, this is the Knative serving. So KSVC is a shortcut for it. So KSVC. So right now you see that I don't have any Kubernetes services. Sorry, Knative services. So what do we do? So let's go for one simple deployment for this quick start. So you can read it a little bit later. I just need a simple program for doing this. Yeah. So now this is the YAML file. You understand this? I'll explain it to you. Here you look at this. This is a CRDs. This service is not a Kubernetes service, a Knative service. Okay, name of the Knative service is hello, and here you are deploying one image which is a hello world go. I think it's a Google image, and the container port is running on 8080. And when you open this one, you will see the hello. I think you will see something like hello world or something like that. Okay, so let me deploy this, copy paste. So I'll go a little bit out of it and create one directory, Knative, and I'll send you all this code to you, and then cd Knative and vi name of the file hello dot YAML. YML will not work. Enter, paste it, done. So good to go. And now I'll just run this command. It will deploy in the Kubernetes default namespace, mind it. Okay, and I just deployed, done. So there's some warning message, you can ignore it. And now get SVC, KSVC. Okay, enter. See here. So this is the Knative services. Now I want to show you everything. Get all Look at this. So it's important to understand when you see this is a Knative service, and now true means is ready to get a request. That means ready to serve your request. Now you know what? By default, when you deploy the Kubernetes service, by default, the uh, number of pods which you see, this is a pod is 2, so you can make it 0 also, that's not a problem. So as part of this pod got deployed, okay, and it has a 2 container, I guess, okay, and here this is the external name, which is a Knative service, and this is a service, this is a private service, and it's a core service, so you can forget about it. So these three things got deployed, and one deployment you got it, one replica set you got it, one configuration for the service you got it, revision you got it, a routing you got it, and again this is serving you got it. So when you deploy one service, which is here, you all these resources got created to make it the traffic incoming. Got it? Hello?
Yes.
Okay, now this is the domain on which the traffic has to come. Now this domain is only accessible within a cluster. That is a problem. And I am somewhere outside. I'm in my desktop. So what do we do in this case? So in this case, I'll have to play around with on this one. I'll show you that in order to access this. So where is my last page? Here it is. And here, this is just a workaround to access this because I have not attached to the DNS. So my this one, this is my node IP address and then port number, and this is my service name. So service name is this one. Okay, done. And now this is my node IP address. I need it. So what is a node IP address for this? So for that, I am going to check the, just a second, hold on. Okay, the problem is node IP address, I have this one. So, and public IP address, unfortunately I did not get it. That means I need to go inside the cluster because public IP address I did not have it. So let's do one thing. Let me connect. This is the problem. I cannot. So IP address is not there. So here also I cannot connect. So how to go? How to go? So basically, how to go inside this? I'm just thinking SSH. Let me just a second, hold on. Using kubectl, how to log in, how to SSH to worker node. Because I have a limitation here, IP address is not assigned because of the EKS cluster. So I need to find out the different way to get inside it. So okay, one thing I have is like I have okay, wait, I don't need this one then. I have an external IP anyways, no? Yeah, sorry, I missed this part. So let's go for this one. And what is the port number for it? So this is the HTTP HTTPS, and this is the one. So let me try this one first. Okay, I think we can connect without that also. So this is my load balancer, and port number is okay. First let's try this one. Okay, so curl and empty. So that means port number is required. Let me try with HTTP first, and it's requesting but it's not coming. Okay, let me check the security group for it. So go for load balancer, and here there's one load balancer which I created, and security group, is it allowing or not? Let me check. And you see that here very strict things we have it. So what I will do, I am deleting everything. It's a bad practice just for demo. Okay, how to delete? Edit, delete, 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 add. Very worst practice, but just for the demo I'm doing. Save it. Okay, now should be okay. And verifying this security group, and everything is allowed. Okay, so now I'm going to try different port number. So this is the one, and one more. This is the one, 96, last one. Should be accessible. Enter, and fail to connect, and last one. Then I have to check the networking. Why it's not connecting? Let me pause the recording. Unpause
This
this.
conference will now be recorded.
Okay, so one steps I did not do that because I'm using no DNS. So before hitting this request, I needed to also allowed this domain local domain to be accessing the from outside, and for that we need to do something like this. Okay, and then when we do this, so earlier if you look at this, my domain was local, so that means it was accessible within a cluster only. Now in order to make it from outside, I did this patching, and then here it got this one, and now after that I should have this kind of this one, and now we can frame this. So 32198, just give me 1 second. So now I can try. So let me quickly try all three. I just want to check which one is working. And fail to connect. Oh, my bad. This one has to be updated accordingly. Copy, and it should be this one, this one, this one, this one. Okay, now let me try. So clear the screen, enter, not working, not working, and last one, not working, and this one, strange. So at least this one should be working. So now what could be the region for this?